So the second part of 9.1 is going to focus on parabolas. And you've experienced parabolas back in Algebra 1, in Algebra 2, and a little bit earlier this year. But we're going to look at them in terms of the general form that we talked about yesterday with the conics. And we're also going to add some new terms about the parabola. So the parabola is a set of all points that are equidistant, which means the same distance from a fixed line called the directrix and a fixed point called the focus. So here in the picture, here, right there is the focus. I'll use a different color. And this horizontal line here is called the directrix. And any point on the parabola is the same distance away. So like this point right here, the distance from the directrix to that point is the same distance from that point to the focus. So those are the same distance, and that will be true for any point on the parabola. Now, so those are two new terms, a focus and a directrix. Now we also have what is called the latus rectum. The latus rectum is a length that connects 2 points on the parabola. So again, it's a chord, and it's parallel to the directrix, and the distance of that, or the length of that chord, is 4p. But that's something new. So what is p? P is the distance from the vertex to the focus. So if I have the focus to the vertex of the parabola is here. So this distance right here, that is p units long. This distance here is also p units long. And this latus rectum here, that is 4p units long. And it's, distance is going to be positive, so it's always going to be the absolute value. Now the axis, we've heard that term before, as the axis of symmetry, or AOS. It is perpendicular to the directrix and goes through the vertex and the focus. So in this example right here, that is your axis. So let's talk about the standard equation of a parabola. So this looks completely different than what we've seen before. We have x minus h squared equals 4p times y minus k. Vertex is still at h comma k that's always been at, but notice that the instead of it having y equals by itself, it's now the x coordinate squared by itself, and that will equal 4p times y minus k. So this is that standard form of your parabola. And we can open up or we can open down. So for opened upwards, here would be our vertex, and at some point here, whatever distance this is to the directrix, this distance here, you would have your focus, and then your latus rectum would go through that focus in parallel to the directrix. This line, like I said, right here, would be your directrix. And then your axis would go vertically perpendicular to the directrix and through the focus and the vertex. Or we could be open downwards, and again, here's your vertex, and this distance would be the same, so that would be your focus, and then this would be your latus rectum. And then back here would be your directrix, and then you'd have your axis going through the focus and the vertex. So like we said earlier, p is the distance between the vertex and the focus, which is also the same distance as the vertex and directrix. If p is positive, we're opened upwards, and if p is negative, we're open downwards. So positive or negative p values. Now, the standard form of an equation of a parabola with a horizontal axis, so a horizontal axis means the parabola is going to open left or right. And you see it looks similar to what we had up here, except instead of it being x minus h squared, it's y minus k squared. You only have one variable that is squared, and that will tell you, whatever variable squared will tell you if it's a vertical parabola opens up or down, like up here, or a horizontal one that opens sideways left or right, like we have down here. All the same characteristics as above is going to be here as well. So we have our vertex, and then this distance and this distance to the focus are the same. And we have that lattice rectum that goes through the focus. That's 4p units long. We got that directrix back here. This time our axis is horizontal, but it's still perpendicular to the directrix. So it goes through the focus and the vertex. Right? And then going the other direction, there's our vertex. And then again, this distance and this distance to where the focus would be are the same. And our lattice rectum is connecting 2 points in the parabola through the focus. This is our directrix. And our axis, again, is horizontal, perpendicular to the directrix. P does the same thing as it did above. If P is greater than 0, it opens to the right, so a positive P value opens to the right. A negative P value opens to the left. So let's go to the next page and look at some examples and draw them. So I'm going to write down both equations up here, so that way we're not flipping back and forth. So we have x minus h squared equals 4p times y minus k, and that's for up or down opening parabolas. Or we have y minus k squared equals 4p times x minus h, and that is for left or right parabolas, or opening parabolas. So if we look at example A, we're trying to find the vertex, focus, axis, and directrix of the parabola and sketch its graph on the graph below. Identify the endpoints of the focal chord. That is the lattice, the focal chord, that is our lattice rectum. So also, we'll sometimes abbreviate. So that lattice rectum is also called the focal chord, the lattice rectum. So if we look at example A, it says y equals negative 1/4 x squared. Well, look at our formula up here. It's y equals negative 1/4 x squared. Notice there's no there's no fraction in front. So what we want to do is get rid of this fraction in front of x squared. So I'm going to multiply everything by negative 4. So that gives us x squared equals negative 4y. All right, there's no h and k value, so our vertex is 0, 0. Now, to get our p value, that number in front of the variable to the first power is 4p. So this means negative 4 is equal to 4p. Divide both sides by 4. Negative 1 is equal to p. Now, because p is negative, that means opens down. And that 1 tells us what that p value is, so we can apply that up here where we know the focus and the directrix are 1 unit away. So I'm going to go and plot the vertex 0, 0. And we know it opens down. We know that the focus is 1 unit away from the vertex. And since it's open downwards, it's going to be here. This is our focus. So our focus is at 0, -1. Our directrix is 1 unit in the other direction. So our directrix is y equals 0. Our axis is going to go through the focus and the vertex in perpendicular to the directrix. So that's going to be x equals 0. So this should be y equals 1. Okay. Now for our other 2 points, our focal chord is equal to the absolute value of 4 times p, which is 4 times -1, which is 4. So that is, again, the length of the lattice rectum. So we go to our focus, which is right here in red, and we're going to go 2 units to the left and 2 units to the right. Those would be the other 2 points on the parabola. So the graph would look like this. Because that lattice rectum or focal chord is 4 units long, because there's 2 units on each side of the vertex, of the focus. So those 2 other points, -2, -1, and 2, -1. So I know that this is a very new way of graphing parabolas, and it's right now probably pretty confusing, but it does get a bit easier. We're not creating a table or anything. We're not having to complete the square. What we do have to do, though, is we have a lot of upfront work to do first, and then once we get our equation into one of these forms, it becomes so much easier. So letter B, we have x minus 1 squared minus 8 times y plus 2 equals 0. Well, notice both formulas don't equal 0. And both formulas has the variable that is squared by itself. So what we need to do is we need to move this whole thing to the other side. So it's going to be x minus 1 squared equals positive 8 times y plus 2. Okay, so now it looks more like this green one. Our vertex is going to be at HK, so positive 1, -2. This is the opposite of what we see. Then we need to work on getting our p-value. So our p-value, remember, is derived from that front term. That 8 is equal to 4p. We divide both sides by 4, p is equal to 2. Since it is positive 2, opens up, and we use 2 to count, so the focal chord is going to be the absolute value of 4 times 2, which is 8. So now, from my vertex, which is at 1, -2, I'm going to go up 2, that is where my focus is, and down 2, that tells me where my directrix would be. So focus is at 1, 0. My directrix is y equals -4. And then my axis goes through the focus and vertex. So the axis is equal to x equals 1. Because notice how the x coordinate of the vertex, when it's a vertical, when it's opening up or down, all that aligns. Now our 2 other points, our p-value is 2, which means our lattice rectum is 8. So from our focus, we're going to go left 4, 1, 2, 3, 4, and right 4, 1, 2, 3, 4. So then we will connect those. And again, this distance is 2. This distance is also 2. This distance here of the lattice rectum or the focal chord is 4 times 2, or 8 units. So then my other 2 points, they are -3, 0 and 5, 0. So this one, they happen to be x-intercepts. All right, now let's look at letter C. Y squared plus 6y plus 8x plus 25 equals 0. Well, y is the variable that's squared, so we want all the y's to be on one side, so we're going to move everything else to the other side, to the right side. So y squared plus 6y, and we're going to have to complete the square as well, but we'll deal with that in a minute. If we minus 8x from both sides and minus 25, then we get this. Now we're going to complete the square with y. So 6 divided by 2 squared equals 3 squared, which is 9. So it's on the left side, it's going to be y squared plus 6y plus 9 equals -8x minus 25 plus 9. So the left side is going to be y plus 3 squared. Let's make this a better looking y. Equals -8x minus 16. So the left side looks like what we needed, but the right side, we got to have it say x minus a number or x plus a number. We have -8x here, so we actually need to factor out a -8, and that leaves us with x plus 2. Now it looks like something we can work with. So our vertex is going to be at -2, -3, because this parabola is switched. The x value is on the right side, and y is squared, which means it's going to be opening up left or right. So that plus 2 tells us that the x-coordinate is -2, and the y-coordinate is -3. So 1, 2, 1, 2. So there's our vertex. Now we have to figure out our p-value. So remember, this is equal to 4p. So 4p is equal to -8. So p equals -2. Yeah, that negative just tells us which way it opens. Because it is open, because p is negative, and it's a sideways parabola, this is going to open left. So opens left. So then our focal chord is going to be the absolute value of 4 times -2, which is 8. Alternatively, you could just take the absolute value of the number in front here, and that'll be the length of your focal chord. So now our focus is going to be 2 units to the left, and our directrix will be 2 units to the right because our p-value is 2. So this would be our directrix. So focus is -4, -3. Directrix was x equals 0 because it's a vertical line going through the y-axis. Now our axis is going left and right, or horizontal. So our axis is y equals -3. Now to get our 2 points, we're going to go from our focus and count in each direction 4 units. 1, 2, 3, 4. 1, 2, 3, 4. So then our parabola will look like that. So those 2 points, we have negative 4, comma 1, and negative 4, comma negative 7. All right, now the last graph here, we have a fraction in front of the right side. So the very first thing I'm going to do is multiply everything by 4 to get rid of the fraction. So it's going to be 4x equals y squared minus 2y plus 5. All right, so now I need to get the y's alone. So we'll subtract 5 from both sides. And I'm going to rewrite this as y squared minus 2y equals 4x minus 5. And then we're going to complete the square with the y. So negative 2 over 2 squared equals negative 1 squared, which is 1. So the left side is going to be, and we're just going to cut to the chase, y minus 1 squared equals 4x minus 5 plus 1. So y minus 1 squared equals 4x minus 4. And we can factor out a 4 from the left side. So y minus 1 squared equals 4 times x minus 1. So now we have our center available. So our center is our vertex. Our vertex is 1, comma 1. So I'm going to go ahead and plot that. Since y is squared, it's going to open left or right. Our p-value, 4p equals 4, p is equal to 1. So since our p-value is 1, from our vertex, we're going to go right 1, that will be our focus, and then back 1 to the left 1 will be our directrix. So the focus is going to be 2, comma 1. Directrix is going to be x equals 0. And then our axis is going to go this way, and it's y equals 1. So look at that horizontal parabola. The y-coordinates of the vertex and focus are the same, and the axis is y equals that same value. The number in front, our 4p, was positive, so that means it's going to open to the right. And our lattice rectum, or our focal chord, is going to be 4 units long. As their focal chord equals the absolute value of 4 times 1, which is 4. So from our focus, 1, 2, 1, 2 to each side. So then our graph looks like that. And again, our focal chord or lattice rectum is 4 units long. And the distance between the vertex and focus and vertex and directrix is 1 unit long, or p units. So like I said, graphing them can be a bit challenging in this new way until you get the hang of it, that it becomes, I would maybe argue, easier than the other methods that we know. All right. Example 2, we're going to write the standard form of the equation of the parabola given this information. So again, I'm going to write this stuff up here so we're not flipping back and forth. Now for these problems, it's going to be important to draw pictures so that you understand, all right, what is this quadratic or parabola going to look like? And that will tell you which form you're using, the horizontal one, left and right, or the vertical one, up or down. So this one says the vertex is at 0, 0, and 2, 16 on the parabola, and it opens up. Okay, so this is your H and K, and I'm going to draw a rough sketch. Vertex is at 0, 0, and the point 2, 16 is on the parabola. So H and K right here. And 2, 6, so it's going to open upwards. And we know a point on here is 2, 16. So this would be an X and Y coordinate. Well, we can take H, K, X, and Y and substitute it into this one up, this equation in blue right here, and then solve for P. And again, we know we're going to use this one because this formula, the one in blue, is for opening up or down, and we're told that this opens up. So let's write out the formula. Okay. And substitute our values. X was 2 minus H, which is 0, equals 4P times Y was 16 minus 0. So the left side is going to give us 4 equals 4P times 16. So we get 4 is equal to 64P, and when we divide both sides by 64, we get P is equal to 1 over 16. Well, now we have to substitute that back in. So X minus 0 squared equals 4 times P times Y minus 0. So again, we're using this formula up here. We're not having to plug in X and Y this time, but we do need to plug in our vertex. And then we can simplify this. X minus 0 is X. We have X squared equals 4 times 1 over 16 is 1/4 Y. So we have X squared equals 1/4 Y as the equation for this parabola. Now, letter B says the focus is the vertex is -1, 2, and the focus is 1, 2. Because these are the same, the y coordinates are the same, that means it is going to open left or right. Because if we look up here, the focus and the vertex have the same y coordinate, and this opened to the right. Same thing over here. The y coordinates are the same here, so it opened to the left. So we know this opens left or right. When we draw a sketch of this, though, we'll be able to determine if it opens left or right. So we have our points. And we have -1, 2 for our vertex. And our focus is 1, 2. Well, the focus is always like inside the parabola. So that means it must open this way. And then the length of this segment right here, that is our p-value. So how long is it from -1 to 1? Well, that's 2 units. So our p-value is 2. So when we write our equation, y minus k squared equals 4p times x minus h. We can substitute in our vertex, and then we can substitute in our p-value. So y minus 2 squared equals 4 times 2 is 8 times x plus 1. And that would be the equation for our parabola. Okay, now this one, the focus is at -4, 2, and the directrix is at x equals 2. Well, if our directrix is at x equals a number, this means it's going to go left or right. And then the focus is going to tell us, give us the definitive, is it the left opening one or is it opening right? Because look at up here, our focus and directrix, the vertex is right in the middle of them. So let's draw this out. Okay. So I'm going to draw this out. Our directrix is at x equals 2. Our focus is negative 4, 1, 2, 3, 4, comma 2. So this is our focus. Okay, so that means the parabola's got to open to the left, this way, okay? Because our parabola does not intersect with our directrix. So we know that the distance between the focus and the vertex is the same as the distance between the directrix and the vertex. So we want to find the halfway mark of this segment here. So we go from negative 4 to positive 2, which is 6 units long. So we want half of that, which is 3. So 1, 2, 3. This is where our vertex is going to be. And that should make sense. If I count 3 more units, 1, 2, 3, I'm now at my directrix. So my parabola opens this way. Because it opens to the left, P equals a negative because opens left. Now, like we were saying, that distance right here from the vertex to the from the focus to the vertex is 3 units long. So that's our P value. So P is equal to negative 3. Now our vertex is at negative 1, comma 2. So that would be our H and K. So if we rewrite our formula, y minus k squared equals 4p times x minus h, and we substitute everything in. So y minus 2 squared equals 4 times negative 3 is negative 12 times x plus 1. And that would be our final answer. So like I said, I know that this is a lot. It's a new way of thinking about quadratics and parabolas that we've never experienced before. So just take your time on your examples and your homework, and these will become significantly easier. So thanks for watching. Make sure to like and subscribe.